Assalamualaikum and hi everyone. See you again. This is part 3 of my lecture on regression and I will focus on residual analysis. In residual analysis, we will examine the pattern of error distribution. What is error? Error is a difference between the y observed value and y estimated value. Okay, where y estimated value is referring to the regression line. When we run the regression analysis, we are not only focusing on the size or the significance of coefficient value, which is referring to the beta or the f statistic, but it is equally important for us to examine the pattern of residual. In order for us to apply the regression equation, it is important for us to ensure that the assumption for regression analysis is not being violated. If the regression assumption are violated, then the regression equation is not valid to be used. So let's see my coming slides in order to know first what are the assumptions for the regression analysis, second how to run the residual analysis, and the third one how to understand the pattern of residual. In assessing the assumption of regression, basically there are two issues that we have to understand. The first one is basically the pattern of relationship between x and y, whether there is a linear relationship. Second is that the error. Error here means the difference between the observed y value, this is the observed y value, and the regression line. The blue line is the regression line. So error here means the difference between the observed value you compare with the estimated value, which is regression line. So basically there are two main things in doing the assumption. Specifically, here we have the simple formula, we call it LINE, line. So these are the things that we should focus on to be more specific in assessing the assumption. So what is LINE? L is representing linearity, okay, which is referring to the relationship between x and y. Second is I, referring to independence of error. Okay, error value are statistically independent. We should ensure that. Third, N, referring to normality of error. Okay, we have to make sure that the error are normally distributed. The last one, E, referring to equal variance, which is the probability distribution of the error has constant variance or equal variance. So we can see here the first one, linearity, referring to the overall pattern of x and y plotted data. I and E, the last three here is about measuring the error. Okay, so how to test the assumption? Okay, so there is a specific analysis, we call it residual analysis. So we have to conduct residual analysis after we run the regression analysis. Let's see how to carry out residual analysis. Okay, to start with, let's say we have this example, the data for calls and sale, and we normally believe that the more the call that we make, the higher the sale would be generated. So let's see, is there any relationship between number of call and the sales volume? First, as usual, we go to data analysis, and then we pick the regression. And then here we put the y data in the range. After that, x data we put here. Okay, we tick label, confidence level here 95%. Okay, output range. Let's say we want to have the output here. Then here the residual, we will take the residual. Here is basically the reading given to us later, the value of errors. Next, the residual plot. Basically, this plot will show the pattern of residual. Then we can make decision whether the assumption violated or not. The line fit plot is basically the actual how the data x, y being plotted, and also the regression line. Last one, we should take the normal probability plot, because the purpose is we want to know whether the error is normally distributed or not. Okay, so now we just click OK. So these are the result. As we know that normally if we want to have very fast indication whether it is whether this has relationship or not, we normally go for the p-value. Okay, here p-value for beta, and it seems like okay, the p-value very small compared to 0.05 the alpha value, so we tend to believe that okay, there is a relationship between call and sale. With here we look at the R square, and then here we believe that 98% of the sale being explained by the variation in call. Okay, so that is the initial decision that we make. But then before we finalize our decision, we have to make sure that whether this regression equation or regression analysis follow the assumption or violate the assumption. First, let's take the call residual plot. Residual plot. We want to see the pattern. I make it bigger here. So, in order to examine the pattern, we should see the zero line here. Okay, zero line here. If for example here, the blue dots here scattered around the zero line eventually, okay, and we can conclude that okay, the distribution is not violate the assumption. Next, okay, we can see the normal probability plot here. Okay, so I just make it bigger. We try to observe the pattern of this blue dot here. If, for example, this dot is approximately form a straight line like this, then we tend to believe that the error of the or the residual is normally distributed. Okay, so that is the information that we get from the normal probability plot. Next, we can also see the third plot here. which is sorry, I make it bigger. This plot showing the actual plotting of the data between the X call and also the Y sales. The blue one is basically representing the real data that we plot, X and Y data. Whereas here the brown color here is basically the predicted sale or the Y estimated line, which is referring to the regression line. So the purpose is that we want to see, we look on the blue dots here. Is there any indication of linear and straight line here? Yes, we can see that pattern, linear pattern. So we might believe that there is a linear relationship between calls and sale. So since the residual plot showing that there is no clear indicator of pattern that violating the assumption, so we may make a conclusion that there is a relationship between the calls and sale. Okay. Okay, I just want to summarize, okay, the result that we get from this analysis just now. Okay, as I mentioned before, if the pattern showing that, okay, that some data are above the zero line, some data here are below the zero line, and they are evenly distributed on the upper side and on the lower side here. So we can say that, okay, the pattern is okay, and the data is linear. First, second, the error is independent, and the third, the error has equal variance. Okay, so by having this pattern only, three conditions are met. Okay, meaning the first one, the relationship is linear. The second one, the error is independent, and the third one is the error has equal variance. If we have this kind of pattern for the residual plot. Next, if we want to see whether the data is normal or not normal, as I mentioned just now, we can observe the blue points here, whether it is form a straight line. If all the point here scattered around the regression line like this, then we believe that the data is normal. Okay, here I will show you another example showing that why we really need to check the assumption of regression. Okay, we have to fulfill the LI and E, linearity, independent, normality, and equal variance. Okay, normally when we have the data, okay, we run the regression analysis, and straight away we will get the ANOVA table and the B coefficient value. Okay, so I would like to stress here, looking at ANOVA table only and B coefficient only may not provide the overall picture. So if we are depending on these two values and then we make decision to reject or not to reject the hypothesis, the decision is not really wise because we are not checking the assumption of the regression whether that being violated or not. Okay, so the p-value in ANOVA table and B coefficient may indicate significant relationship, but the regression line is not valid if, okay, the residual plot show the pattern which is again the assumption. So let's go to the second example. We have the X and Y data here. Then we run the regression analysis. So this is the output. Initially, we may think that okay, the X and Y is significant since the p-value for X is small, less than 0.05, and the relationship will be moderate. Okay, with R square 0.33, we may say that initially that there is a moderate relationship between the X and Y at a significant level of 0.05. But wait, we cannot come to that conclusion yet. We have to see the residual analysis. Okay, so this is the residual plot that will produce together. Okay, together with in regression analysis. So meaning that we have to study the pattern. Is it the blue dots here above the zero line and below the zero line evenly distributed, or there is a special pattern? So what I can see here is that here the pattern is look like curve here. It is not evenly distributed above the zero line and below the zero line. So it means that based on the residual plot, the assumption of linearity and independent of error is violated. Okay. Next, uh, we see also the normal probability plot. Okay. So is there any clear indication that the blue dots here form a straight line? So we can check with this straight line here, and it seems like okay, there is up and down, a kind of special pattern, cyclical pattern here. Okay, so it is not really a straight line. So from this we can conclude that okay, this regression data, the X and Y data, when we plot this data, basically violating the regression assumption. Thus, the regression equation here is not valid to be used. And finally, I would like to show you some pattern of residual plot which indicate the violation of assumption. First, here, if we can see a kind of trend patterns, okay, and here the second one is like a cyclical pattern, up and down pattern. These two indicate that the error or the residual are not independent. Lastly, if the pattern here is like funnel type, okay, this will indicate the not equal variance. The error is not equal variance. So those are the indicator for the pattern of residual plot that you must aware, and then that will help you to make a decision whether the regression line or the regression equation is valid to be used or not. Thank you.